This section is more about measures of spread. So we already talked about the range. So the range is the max minus the min. So when you do the range, a common mistake is for people just to write 51 minus 35 or 35 to 51. Just write 16, okay? Actually do the max minus the min. And the interquartile range is going to be Q3 minus Q1. And it helps us to calculate outliers like we did in the previous lesson. So to calculate the outlier, what you want to do is do Q1 minus 1.5 times the IQR. And to find the other extreme, you're going to do Q3 plus 1.5 times the IQR. Those are two types of spreads. We also have what's called the standard deviation. So the standard deviation is using this symbol right here, and you will find this on your calculator as well. Okay, this symbol is for standard deviation. So this right here means what you're going to do, remember the sigma means sum, is what standard deviation is you're going to take each number, find the difference between that number and the mean, square that, and add those up. That's what that sigma means. And you're going to divide by how many numbers there are, and then you're going to take the square root of it. That's a long process to find the standard deviation. But the standard deviation is the dispersion or variance of a data set. Okay, how varied it is. So the greater the population sample, the lower the standard deviation will be. Okay, so the more people you ask or sample about something, the closer you're going to get to the actual true value of the answer. So to find it on your calculator, you're going to go through and do the stat, calc, first variable statistics, and then you want to look for the standard deviation symbol. So there's a couple different types of standard deviations based on what textbook you're using, but we are using the one that has this symbol. Okay, look for that symbol for standard deviation. So a z-score is the number of standard deviations a number is away from the mean. So it helps us determine how far from the average something is. So you can have a positive z-score. So if this is the mean, anything in this data set over here would have a positive z-score. Anything over here would have a negative z-score. Okay, so if I put numbers on here, if the mean is 10 and the standard deviation was 2, this number would be 8. So if you try to find the z-score, you're using this formula. So in this formula, this symbol can actually stand for the mean. So it's going to be the data. So if your number, let's say, is 8, you would take 8 minus the mean, so the mean is 10, and divide it by the standard deviation, which is 2. So that's how you're going to get one standard deviation away, but it's actually the z-score is going to be -1. Z-scores can be decimal too. So let's say that this data over here was 13.2. So to find the z-score, or the data was 13.2. So what you would do is you take 13.2, you'd subtract the mean, so the mean is 10, and then you would divide by the standard deviation. We're given the standard deviation is 2. So you would do 13.2 minus 10 and divide by 2. And you're going to get a positive value, which is you'd get 1.6, and it's positive because 13.2 is greater than the mean. Okay, example 1. So on your calculator, I'm going to find the mean and the standard deviation, the nearest hundredth. And then I'm going to do that on my calculator and press pause. So I'm going to go through edit, stat, first variable statistics. So the mean to the nearest hundredth, remember the mean symbol is this x bar over it. So the mean is 6.07 to the nearest hundredth. And the standard deviation is this symbol. So the nearest hundredth, that is 2.67. So question, within how many standard deviations of the mean do the data lie? Show your work on a number line. So what you want to do is, I'm going to make a line right here, and I'm going to put the mean in the middle because it's within the mean. So this is 6.07. So if you add a standard deviation, so if I do 6.07 plus 2.67, I get 8.74. And I can also subtract a standard deviation. So if I do 6.07 minus 2.67, I get 3.4. So this right here is one standard deviation away from the mean. This is one, and this is one. So check your data set. Have we included all the numbers? Is every single one of these numbers at least 3.4 and less than or equal to 8.74? Nope, because I still have 14 and I have a 2 and a 3. So now I'm going to add one more standard deviation. So I'm going to add 2.67 again. So I do 8.74 plus 2.67, and I get 11.41. And I'm going to do 3.4 minus 2.67, and I get 0.73. So this represents 2 standard deviations away. So this would be 2 and 2. So again, I have not included 14 yet. I've included 2, so I'm going to have to go up another standard deviation. So I'm going to have to do 11.41 plus 2.67, and I get 14.08. So if I go up again, 2.67, I get 14.08. So that's 3 standard deviations away. So within how many standard deviations? The answer is 3, and that's how I show my work. Okay, what is the z-score of each? So if you have 5 in the data set, how do you find the z-score? Well, you do 5 minus the mean, 6.07, and divide it by the standard deviation, which is 2.67. So 5 minus 6.07, divide that by 2.67, and I get negative 0.4. So it's a negative number, which makes sense because 5 is less than the mean. Then I'm going to do this one. I'm going to do 7 minus 6.07, and then divide it by 2.67, and I get 0.3, approximately. I'm rounding. And the last one, 14 minus 6.07 divided by 2.67, and I get 11.7. This one doesn't seem right. So it doesn't seem right that I'd be 11 standard deviations away. So I made a common mistake on my calculator. So I'm going to make sure to put 14 minus 6.07 in parentheses and then divide it. So this is 2.97, which is about 3.0 if I round. So about 3 standard deviations away, which made sense right here. Determine if there are any outliers. So remember, if you have any outliers, what you want to do is take your Q1 and subtract 1.5 times the IQR. Then you're going to take your Q3 and you're going to add 1.5 times the IQR. So I'm going to go back to my statistics that I had in here. So calc, first variable statistics, and I'm going to look at my Q3 and Q1. So my IQR was 7 minus 5, which is 2. And my Q1 was 5, and my Q3 is 7. So I'm going to calculate 5 minus 1.5 times 2, and then I'm going to do 7 plus 1.5 times 2. So 5 minus 1.5 times 2 is 2. Could do that without our calculator. And 7 plus 1.5 times 2 is 10. So are there any numbers that are less than 2 or greater than 10? That would be an outlier. So in this situation, 14 is an outlier. So my outlier is 14 because it's greater than 10. Okay, example 2. Suppose you can't swim and you need to cross a river. A guide tells you the average depth is 2.5. Which river would you rather cross? The numbers below represent data points of depth in feet at different points across 3 different rivers. So which one would you rather cross? A, B, or C? So I would want to cross river A because if it's 2.5 feet and you can't swim, here if it's 6 feet, you're gonna struggle. 6 feet, 6 feet, 6 feet, you're gonna struggle. 8 feet, 8 feet, 8 or 6 feet, you're gonna struggle. So even though that the averages might be the same, your best bet is A, because in this case, this is an example of standard deviation, because the standard deviation will be less because the numbers are not as spread out. Okay, there's less variance in the numbers. Okay, example 3. And I should go back, but you can actually calculate the standard deviation for each of those 3 rivers, and then see which one is less, which I can see off the bat that river A is going to be have the least standard deviation. So this is kind of an interesting example. Stan earned a 680 on a math of the SAT. The SAT score distribution is normal with a mean of 500 and a standard deviation of 100. Al scored a 27 on the math. The ACT score distribution is normal with a mean of 18 and a standard deviation of 6. Who did better on the respective test? Do you ever wonder how they figure out how they do that? Well, what you're going to do is you're going to calculate the z-score for each. So we're going to find the z-score for the first person's name was Stan SAT, and then Al ACT. So the person that has the higher z-score, so if you think about the z-score, this would be your mean. The person that has the higher z-score, 1 standard deviation away, 2 standard deviation away, the higher that your score from the mean with respect to standard deviations, the better you did on that test. So to find the z-score, what you're going to do is you're going to take the score. So it's hard for me to read these scores right here. So the score for Stan earned was 680. So you're going to take the score minus the mean and divide by the standard deviation. So if I do 680 minus 500 and divide by 100, I get 1.8. So Stan's z-score is 1.8. If I do Al scored a 27, the mean is 18, and the standard deviation is 6. So 27 minus 18 divided by 6 is 1.5. So Stan actually did better because his z-score is greater.